You know that moment. You're staring at a carton of milk, you look at the date, and you just wonder, is this still good? Well, today, we're going to unpack the science behind those dates and find out what they really tell us. Because that one simple question, what does this date actually mean? It opens up this whole fascinating world of sensory science, predictive math, and believe it or not, global logistics. It's a journey that starts with our own taste buds and ends up in the massive worldwide cold chain. So, first things first, what even is shelf life? The official definition says it's the time a product is both safe to eat and has an acceptable quality. Now, safety is one thing, but that second part, acceptable quality, well, that's where things get really interesting. You see, quality is a surprisingly complex idea. It's way more than just, is this going to make me sick? It's about the entire sensory experience of eating. When we talk about food quality, our minds immediately go to the obvious stuff, right? Taste, smell, how it looks. But the science of shelf life has to go deeper. It accounts for all the things we can't see, like the invisible growth of harmful bacteria, or the slow, steady loss of important nutrients, like vitamin C disappearing from your veggies. So, if a huge part of shelf life is our perception of it, how on earth do scientists measure something as personal and subjective as taste? Well, they've got a system for it, and it is surprisingly rigorous. It's a process called descriptive sensory analysis. And look, this is not your average focus group with some chips and dip. It's a hardcore scientific method designed to turn our very human, very subjective perceptions into cold, hard, objective data. The whole process is incredibly detailed. First, they recruit and train a panel of testers. Then, and this is the crucial part, that panel works together to develop a shared, super specific vocabulary to describe every aspect of the food. This makes sure that everyone is speaking the exact same language before the real testing even begins. And get this, we're not talking about a quick afternoon session. The training for one of these panels can take anywhere from 80 to 150 hours. That's a serious, serious commitment to getting objective, reliable results. This quote really gets to the heart of it all. The goal is to train people to switch from a hedonic or pleasure-based response, saying, I like this, to something purely analytical. They learn to describe, not to judge. They basically become human instruments that can precisely measure attributes like a high note of citrus or a granular texture. Okay, so once we've established a baseline for what good is supposed to taste and feel like, the next obvious step is figuring out what makes it all go bad. And that brings us to the science of spoilage, all the factors that cause those carefully measured qualities to change over time. Scientists split these factors into two big groups. You've got intrinsic factors, which are characteristics of the food itself, things like its acidity, its water content, any preservatives they've used. Then you have extrinsic factors. These are all the outside influences, like how it's processed, the packaging it's in, and most importantly, the temperature where it's stored. And let's be really clear about this. Temperature is the undisputed king of all extrinsic factors. More than anything else, the temperature of its environment determines how quickly a food product will spoil. It's the one variable that has the most power, for good or for bad. Because temperature is so incredibly critical, it also happens to be our best tool for making predictions. If we can track temperature, we can use data to actually forecast the future of a food's shelf life. So this is where it gets a little technical, but stick with me. These two formulas, Arrhenius and Q10, are pretty much the cornerstones of predicting food spoilage. Now, they might look a little intimidating, but their purpose is actually really simple. They calculate precisely how much faster the chemical reactions that cause spoilage happen as the temperature goes up. Here's a great way to think about it. Imagine that every food product has a spoilage clock. At the perfect cold temperature, that clock ticks nice and slow. But as things get warmer, these formulas prove that the clock starts ticking exponentially faster, just burning through that product's shelf life. Of course, a fancy mathematical model is only useful if it actually works in the real world. That's why scientists are constantly checking these predictions against real-life experiments. And what you see here is proof that the math holds up. The model's prediction for sweet oranges, that's the green line, is almost a perfect match for the actual experimental data shown in black. So let's see this whole system in action. On the left, you've got a shipment of grapes that was kept at a nice, stable, cool temperature. The model says it's low risk, with a solid 22 days of shelf life left. But look at the tuna on the right. It went through some major temperature swings. You can see its shelf life just takes a nosedive, flagging it as high risk and showing hundreds of days of freshness just gone. Now, this isn't just some cool academic exercise. Applying the science has a massive, massive global impact, especially when you think about the billions of tons of food that are moving around the planet every single day. Getting this right lets us do 3 absolutely critical things. 1, we can identify and pull food that could actually be dangerous. 2, we can remove products that, while safe, just aren't going to meet quality standards anymore. And 3, and this might be the most important, we can reduce so much waste by proving that food is still perfectly safe and good to eat, even if it had a bit of a bumpy ride. What we're really looking at here is a way to manage food quality and safety based on real science and hard data, not just a random date stamped on a box. It's a system that can be scaled up to monitor everything moving by sea, rail, road, and air, all across the world. So, this leaves us with a pretty powerful question, doesn't it? In our incredibly complex, interconnected world, could this combination of sensory science and predictive data be the real key to unlocking a food system that's not only safer, but also way smarter and a whole lot less wasteful for all of us? It's definitely something to think about the next time you're checking that data.